All right, in this video, we're going to be talking about polarity and covalent bonding. We want to be able to distinguish between the two, polarity and nonpolar covalent bonding, and then be able to predict which end of a polar bond between identical atoms is positive and which end is negative, and then rank bonds in order of increasing or decreasing polarity. So that's what we want to do here. So nonpolar bonds, if you remember, is a bond shared equally. Okay, so here's two kids playing equally with toys, okay, between two nuclei, and the charge density is centered in the region between the bonded atoms. Okay, a bond between identical atoms is always nonpolar. Polar covalent bonds then is not sharing equally, like these two children here with the burger, okay? They're shared unequally between the nuclei. One atom has more electron density than the other, or more of the electrons than the other, okay? So here's some examples. So nonpolar covalent bonding equals sharing, okay? Two identical atoms. Polar covalent bonds are unequal sharing, so more of the electrons are on one side than the other, okay? And then ionic bonding is transfer of an electron. That's what we saw. One is actually losing an electron completely, and one is gaining an electron. And here's an example of that, just showing if this is electron density in blue, this is between hydrogen and fluorine atoms, most of the electrons are over by the fluorine, and we'll see that as we go through these examples together. Okay, so here's another trend kind of in the periodic table, or another thing we can glean from the periodic table, something called electronegativity. So bond polarity in covalent bonds may be described in terms of electronegativities of the bonded atoms. So this is a whole list of electronegativities here. It shows kind of the trends, and you can have a table like this. There's some in your textbook as well that list all the electronegativities of the elements here. So we're going to use this as we talk about, is a bond polar, nonpolar, is it sharing, not sharing, etc. Okay, so in general, electronegativity increases from left to right across the periodic table and decreases from top to bottom down a group. Trends in electronegativity values of common elements are shown here. So fluorine is really electronegative, oxygen, nitrogen, etc. And so the equal sign there means they're basically the same in electronegativities. Okay, so the polarity of a bond can be estimated by calculating the difference between the electronegativity values for the bonded elements. So for example, if we had a carbon and a fluorine bonded together, okay, you go back to the table, you look up the electronegativity value for fluorine, which is 4 here, and carbon, which is 2.5, and you take the difference, and that gives you a value. And that bond is more polar than a carbon-hydrogen bond, and these are their values off the periodic table. The difference there is only 0.4. So the higher the value of this difference, the more polar the bond is, okay? So the bonding electrons are displaced toward the element with the highest electronegativity value. So here if we had hydrogen, which is 2.1, and fluorine, which is 4.0, the electrons are going this way towards fluorine, okay? So that's what we're seeing here. All right, so here's an example then. Arrange the following bonds in order of increasing polarity and place an arrowhead pointing towards the element that will act as the negative pole. Okay, so if we just look at the periodic table here, all right, so hydrogen is 2.1. Okay, so hopefully you can see that there. Hydrogen is 2.1 for all these guys. Okay, and then oxygen is 3.1. Okay, sulfur is 2.5. Phosphorus is 2.1. And carbon is also 2.5, I believe. Yeah. Okay. So let's take this difference. We're going to take the absolute value. We're not going to worry about negative numbers, right? So 3.5 minus 2.1. So for the hydrogen oxygen, this is going to be 1.4. This is the difference, 3.5 minus 2.1. Again, bigger number minus a smaller number. It's the easiest way to think about it. Hydrogen, sulfur. We take that difference, 0.4. Hydrogen, phosphorus, 0. Hydrogen, carbon is 0.4 again. Whoop. Don't want to do that. No, hold on. I don't want to quit. Keep. Okay, hold on. I hit the button to get out of the slideshow. There we go. Okay, so let's get back into this. Okay. So if we arrange these in order of increasing polarity, okay, it would be, let's see, where am I going to write this? So increasing polarity, I'll just write it up here. It's going to be phosphorus, hydrogen, hydrogen. I'll just write it the way it's written here. Sorry. Hydrogen, phosphorus, hydrogen, sulfur, which is equal to hydrogen, carbon, then hydrogen, oxygen. Okay. So now, if I was, let me just erase here to write, maybe it won't let me erase there. Let's see, so the poles here then, let's see, oxygen is more electronegative than hydrogen, so it's going to point that way, the electron density. Sulfur is more electronegative than hydrogen, so it's going to point this way. There's going to be really no pole, okay, between the hydrogen and the phosphorus because the difference is 0. And then here again, the hydrogen and carbon, the electrons are going to go slightly to carbon, okay, because it has a slightly higher value than hydrogen. Okay, so that's electronegativity. And in the next video, we're going to be talking about multiple bonding. So see you then.